Hey guys, I'm back again today with the Creality Ender 7, and I'm hoping this is the last supporting modification that needs to be done before we can do a Klipper install and really get things moving on this machine. Now, to get things moving, we need to get more plastic flowing, and I reached out to Bondtech to see if they could support this project, and they did not disappoint. They sent me the LGX Lite extruder, and they got Slice Engineering to hook me up with the Mosquito Magnum hotend. And so in this video, we're gonna be taking a look at what's involved in getting those two pieces of equipment installed onto the Creality Ender 7. And so of course, I would like to send a big thank you to Bondtech, Slice Engineering, and also Mech Solutions for being the ones who originally provided me with this printer to experiment with. We're gonna start off by trying to benchmark the Ender 7 hotend. And the reason for doing this is that Creality markets the Ender 7 hotend as having some kind of higher flow capacity than the regular Creality machines. I'm going to be using this particular benchmarking test from Stefan from CNC Kitchen, so thanks to him for that. And I've edited the G-code to work on the Ender 7. And what this does is that it prints out a sequence of blobs at various temperatures, so 230 degrees, 210 degrees, and 190 degrees Celsius, and it increments the flow rate. Then you take the extrusion blobs, you weigh each one, and you insert those values into an Excel sheet that Stefan also made. The Excel sheet then plots the data, and what you should see in theory is a drop off between the requested flow rate and the actual flow rate. The decline in actual flow rate, or under extrusion, should increase as the nozzle temperature drops. And this will become more prevalent as you request a higher flow rate from the hotend. Now, this is the general trend that I observed, but my data was not nearly as clean as Stefan's. I suspect that one of the reasons for this is that prior to this experiment, I was running a lot of carbon fiber filament through the brass nozzle, and I do believe that it is no longer a 0.4 millimeter nozzle. And so even with PLA, I experienced a lot of stringing and oozing, and I feel like that somewhat fouled my results. Also, as a result of the suspected larger orifice, I do believe that the flow rates are also skewed, and so I ran the test again with even higher flow rates to see if I could get an even more prevalent drop off in extrusion. And according to this second test with the higher flow rates, you really see this hotend start to drop off at around the 18 cubic millimeters per second requested flow rate at the lower extrusion temperature of 190 degrees Celsius. The tests at the two higher extrusion temperatures of 210 and 230 degrees Celsius do not seem to drop off at all the way up to 22 cubic millimeters per second. And this is a much higher flow than what I've seen this hotend be able to do in practice. And so when I go to tune my high-speed printing profiles in the slicer, I pay close attention to the volumetric flow rate. And before this nozzle got bored out by the abrasive filament, I would say that around the 15 cubic millimeters per second mark is when I started to see noticeable under extrusion in my parts with the stock Ender 7 hotend. Now, unfortunately, I didn't have a spare Ender 7 nozzle to run the tests more reliably, otherwise I would have. But if you guys have an Ender 7 and you're interested in benchmarking this hotend and reporting back in the comments, the G-code file will be available for download in the video description down below. And now that we have a slightly better understanding of where we're coming from, let's take a look at where we're going. This is my CAD mockup of the LGX Lite combined with the Mosquito Magnum hotend mounted on to the Ender 7 X-carriage bracket. This setup comprises of four main parts. So in yellow, you have the fan grill. In blue, you have the fan ducts, which the part cooling fans mount to. And behind the hotend fan, you have the mount for the Mosquito Magnum hotend, and that's pictured in orange. I intentionally made this a separate piece from the red mount, which mounts the LGX extruder to the Ender 7 X carriage. And the purpose for this is that in the future, if I ever want to switch hotends, I can do that by simply swapping out that bracket, and in some sense, this makes this design modular. In the meantime, I suspect that the Mosquito Magnum hotend will more than meet my requirements. Now we can begin with the disassembly of our current equipment, and the first thing you need to do is remove the filament from your Bowden tube. Just preheat your nozzle, use the lever to release the tension on the filament, and give it a good pull. And with the printer still on, lower the printer down so you have maximum access to the hotend from all angles. And if you guys haven't seen my other video about my triple lead screw upgrade, go check that out. I'll put a link in the top right hand corner of the screen, and you guys can actually purchase this upgrade for yourselves on my website, embracemaking.com. Start disassembling the print head by removing the 4 screws that hold each of the part cooling fans onto the fan shroud. Be careful not to lose these screws, as we will be reusing them later. Now you can head to the back of the print head, where you can access the 2 M3 screws that secure the fan shroud. With those 2 screws removed, you can now simply pull the fan shroud off. There are 2 plastic tabs that hold the fan shroud onto the X carriage as well, so just be careful not to break those. This now exposes the heatsink cooling fan, and we can use our hex key to remove the 2 M3 screws holding the fan to the heatsink itself. There are 2 aluminum spacers wedged between the fan and the heatsink, and you will not be needing to reuse those, but they'll likely fall out during the removal of that fan. Now you can remove the Bowden tube by removing the retaining clip, pushing down on the fitting, and pulling up on the Bowden tube. Now, it's not uncommon for the Bowden tube to get fairly stuck, and that's likely because of hardened plastic near the bottom of the tube. And so if you have to, you can turn your printer back on, turn your nozzle temperature up, and then pull on the Bowden tube, and it should release much easier. Just be careful, because you'll be working around some very hot parts. Remove the heat block sock, and then take a look under the heater block for 2 small grub screws that are holding the heater cartridge and thermistor into place. Loosen them liberally. You can now remove the heater cartridge and thermistor from the heater block. Do not pull on the wires, as you may damage them. They could be brittle from all of the heat cycles. Rather, you can push from the other side using one of your hex keys. Now you can remove the 4 screws holding the hot end into place, and you should be able to completely remove the hot end from the X carriage bracket. Cut any zip ties holding the wiring harness into place. My wiring harness might look a little different from yours because I've installed a CR Touch, and I've done that in another video. If you guys want to check that video out, the link will be in the top right hand corner of the screen. Now we need to remove the plastic shroud at the top of the printer, and there are 4 M4 button head cap screws at the front and 4 at the back. After removing all 8 button head cap screws, take a look at the sides of the shroud beside the vertical pillars of the machine. There should be slots in the shroud, and you should be able to get a flathead screwdriver in there to pry up and release the shroud from the main plate at the top of your 3D printer. It can be frustrating to get this piece to finally release, so take your time and try not to break it. When you do finally get it to release, move to the back of your printer and remove the large electrical connector. You can now access the breakout board where all of your printhead connections go to. It's a tight space to work within, so we're going to take a look at which connections we have to remove, and I'm going to do my best to get some good shots of that. I'm going to be disconnecting all of the connections that run back to the printhead, and that white one that I just had in my hands there, that is for the thermistor. There is the red and black wires that go to the extruder fan. There's the 2 thicker large red wires, and that is your heater cartridge. And beside that, you see blue and yellow wires. There's 2 of those connectors, and those are the part cooling fans. And then beside that, there is 2 black wires with a label that says X on it, and that is the X limit switch. If you look very closely on the PCB, all of these connectors are labeled, and some of the wires have labels on them as well. I'm going to be pulling all of these connections out because I'm going to be running a new wire loom. But if you plan on reusing the Creality wire loom, you only have to pull a few of these out. The one that you see me pulling out right now is the part cooling fan on the left hand side of the fan shroud. The reason you have to pull this one out is because we're going to be printing off a new part cooling fan shroud, and the only way to get that fan to release from the existing fan shroud is to pull it through that whole connector side out first. At minimum, you will also need to pull out the existing heater cartridge wire, as well as the X limit switch wire. And in my case here, I'm running a CR Touch, and so I'm going to pull that one out and through that little window in the X carriage bracket. What you should be left with is a very bare looking X carriage bracket ready for the new parts to be mounted. And speaking of new parts, let's take a look at what we're going to be installing. So first up from Bondtech is the LGX Lite extruder. It comes nicely packaged in this box, safely sitting in a generous amount of foam. And included with the LGX Lite extruder is some mounting hardware for the extruder itself. Bondtech also sent me their CHT coated brass nozzle pack. So this comes with 5 different nozzles in the 0.6, 0.8, 1mm, 1.4mm, and 1.8mm sizes. And that is definitely going to be for some high flow applications in the future. For the time being, I'm going to be testing the machine with the regular 0.4mm CHT nozzle, and we'll take a look at that in a second. And in the final box is the Mosquito Magnum hot end from Slice Engineering. Now, I don't know what type of packaging this is called, but oftentimes I see it used in machine tooling. Either way, it is very difficult to get open. But I guess it ensures that your parts arrive in one piece and in good condition. I've also heard that these lollipop things that they include are absolutely phenomenal, but I've yet to try them. What I'm definitely more excited about is the Mosquito Magnum hot end itself. Now, I've used this hot end before in another kit combined with a Bondtech DDX extruder in the past on a Creality Ender 5 Plus, and it was phenomenal. So I'm expecting similar results. Bondtech also sent me this aluminum mount that allows you to mount the Mosquito Magnum hot end directly to the bottom of the LGX Lite extruder. Now, I won't be using this bracket and you won't be needing it for the Ender 7 application, but it is something that they sell on their website if you're cooking up your own custom application. In addition to all of the main components, Slice Engineering and Bondtech also provided me with all of the smaller bits and pieces like the heater cartridge, thermistor, boron nitride thermal paste, etc. I'll put a full link of all the parts that I've used for this project in the video description down below. And so a big thank you is in order for Bondtech and Slice Engineering. Before assembling anything like I did here, there's a couple holes you're going to need to tap for M3 threads. So these 2 small holes underneath of the extruder at the back of the extruder mounting bracket, as well as this hole here on the hot end mounting bracket, this one here, and that one there. If you don't have an M3 tap, the threads from the M3 screws will likely self-tap into plastic anyways. Now we can jump into the assembly of these parts, and the first thing you are going to need to do is remove the 2 screws holding together the Bondtech LGX Lite extruder. Keep a firm grip on the entire assembly, because once you remove these 2 screws, the whole thing will fall apart in your hands if you don't have it all clamped together. You can flip the extruder upside down, simply remove the motor. Now you're going to remove that middle spacer plate, and you're going to be replacing that with the 3D printed bracket for the LGX Lite that I've provided for you guys in the video description down below. You'll find links to all of these files. You can also find them for sale on my website, embracemaking.com. If you want to have these parts printed in a higher quality material, I can do that for you, and you can ensure you get the best quality installation parts for your machine. Now, using the same screws that you just removed, you can put them back into the assembly and tighten everything down. Remember that a lot of these parts are plastic, so you don't need to over tighten them and crack anything. Now we can take the Mosquito Magnum hot end along with the 3D printed bracket and the M2.5 by 6mm long socket head cap screws from the Slice Engineering Mosquito Magnum mounting kit, and we're going to combine these items. So you're going to take that Mosquito Magnum hot end, slip it into the bottom of the bracket like so. You're going to have the Slice Engineering logo facing forwards, and then in the top 2 outermost holes, you're going to install those M2.5 socket head cap screws, and they should fit right through the top of the mounting hole locations in the top of the Mosquito Magnum hot end. This mounting bracket sits very close to the heater block on the hot end, and so you're going to want to print this part in a material with a higher heat resistance than something like PLA. Air from the extruder fan is constantly blowing over this part through the heatsink, but I wouldn't take any chances and still try and print it in the highest temperature resistance material that you can. Installation of the nozzle is next, and I've already showed you guys this nozzle pack from Bondtech, and so these are coated CHT nozzles, and CHT stands for Core Heated Technology. This is a very interesting concept from Bondtech, and you can see the 3 cross-drilled holes inside of the nozzle. This will effectively split up your filament into 3 separate channels, increasing the amount of hot surface area that your filament is touching, which should provide you with a higher melting rate. Now I'm going to be using the 0.4 millimeter nozzle for the hot end benchmarking test, and these nozzles are coated in nickel, so that's not going to greatly increase the resistance to abrasive filaments, but it is supposed to decrease the friction and increase the flow rate. I believe on the Bondtech website they do say that they will be coming out with hardened versions of these nozzles in the future, so be on the lookout for that. But in the meantime, other hardened nozzles will fit as long as you have the correct thread and thread length. Now we can install the thermistor and heater cartridge. The thermistor is rated to 300 degrees Celsius and the heater cartridge is the 50 watt version at 24 volts. I'm going to be showing the Bondtech thermistor being installed into the hot end. However, at the time of the making of this video, there is no firmware available for the Ender 7 that will accommodate the 300 degree thermistor from Bondtech. I compared some of the resistance tables between the Bondtech thermistor and the Creality thermistor, and at around the 220 degrees Celsius mark, there would be about a 15 degree difference between the two, and so I decided not to run the Bondtech thermistor for now. Until I migrate to Klipper firmware, I'm going to continue to use the Creality thermistor, and this is unfortunately going to limit my nozzle temperature to 260 degrees Celsius, but at least the readout will be accurate for now. Hopefully Bondtech or some other third party will eventually release a Marlin configuration file that's compatible with the Ender 7 so you can switch thermistors. While I've been talking about the thermistor details, you can see in the video clip that I've removed the single retaining screw on the side of the heater block that retains both the heater cartridge and thermistor, and now I'm applying some of the boron nitride thermal paste to the inside of those bores. The Bondtech thermistors usually come with a small filler piece that slides in before the thermistor, and this takes up the remaining space inside of the thermistor bore. My package did not seem to come with one, and so I'm going to be relying on that boron nitride thermal paste to dry up and retain the thermistor along with the single retaining screw. That in combination with some good wiring management, and I don't suspect that my thermistor will be moving around at all. At this point, you're also going to need to cut a small piece of PTFE tubing to go between the hot end and the extruder. This piece should be cut to 38 millimeters in length. Make sure you cut the ends as square as you can, and having one of these PTFE tube cutting tools is very handy. You can find printable versions of these tools online, and they can be downloaded for free. The PTFE tube will drop right in through the top of the hot end mounting bracket, and then you can go get the left side part cooling fan that you removed from the wiring harness earlier. The reason that you need this fan right now is because we're going to be taking the wiring and we're going to be putting it in through part of the cable management system that's built into the LGX mount. I integrated this wiring channel into this bracket to clean up the wiring a little bit, and it runs behind where the PTFE tubing will be situated. So we need to get this wire inside first. You can simply just push those wires down inside of that channel and leave enough slack on the fan end for the installation of the fan. And then you can take the two pieces and slide them together so that the PTFE tube now also inserts into the bottom of the Bondtech LGX Lite extruder. If you cut your PTFE tube to the correct length, all of the holes going through both of the brackets should now line up. Bend your thermistor and heater cartridge wires up into the strain relief portion of the LGX mounting bracket and loosely retain them with zip ties. Take your assembly back over to the printer and then grab your X limit switch coming through the window of the X carriage bracket, and now you're going to slip that X limit switch connector through the window on the Bondtech LGX Lite extruder mount. Fish that connector and wire up through the strain relief portion of the LGX mounting bracket, and then you can take the entire assembly and slip it right directly on to your X carriage bracket. Your new equipment should slip directly on top of the mounting posts on the Creality X carriage bracket. At the back of the printhead, you can now take some M3x10 socket head cap screws and install them through the holes that were originally holding the original Creality fan shroud into place, and these will thread directly into the LGX mounting bracket. In this clip, you can also see the orientation in which I clocked the LGX extruder motor such that those wires will be facing downwards and to the left, and this will make for a very clean wiring installation as well. And now we can take those wires and that connector from the motor and we can fish them under and through the X carriage bracket and out the front side of that little window. On the front side, your motor wiring harness will pass up and through the strain relief bracket, and right now in the opposite direction, I'm feeding down the CR Touch wiring harness. If you're running a CR Touch like I am, then that connector will pass through the window in the opposite direction towards the back of the print head. It can then be wrapped around the X carriage bracket and plugged back into the CR Touch module. And now you can secure the hot end mounting bracket using two M3 socket head cap screws. Anything from 6 to 10 millimeters in length will be sufficient. You can also see here that I have the extruder fan and the right side part cooling fan hanging in place, and those wires are also passing through the strain relief. I'm going to start pulling on these wires and positioning the fans such that the wires have enough slack they should be able to reach their positions on the fan shroud. Now I can take the fan shroud and the grill will simply just pop into the fan shroud. There are two retaining clips and you'll see the receptacles for them on the fan shroud, and it should just push itself into place and not come out. It will be very secure. Then you can take the two part cooling fans and face the outlets of the fans down into the fan ducts. On the left-hand part cooling fan, the wires should wrap themselves behind the part cooling fan and through the channel on the part cooling fan shroud. On the right-hand side part cooling fan, you'll find that the wires are aligned with the rear of the part cooling fan shroud, and so there's a much smaller channel that the wires will run through. Secure the part cooling fans with the original hardware. Those M2.5 screws will self-tap into the part cooling fan shroud. Note that on the left-hand side part cooling fan, the bottom left-hand corner screw will not be used. So you will only use 3 of the screws on the part cooling fan on the left-hand side. Now as for the extruder fan, this will be positioned in between the part cooling fan shroud and the hot end. In this video clip, you're going to see me rearrange some of the wires, and you're going to need to push those thermistor and heater cartridge wires inwards such that the part cooling fan shroud can wrap around them. And you're going to want to make sure that none of the wires are pinched. It is a tight fit, but everything will fit. I had to design the system such that all of the new equipment fits within the original envelope of the Ender 7 printhead. And this is because the amount of space available inside of the printer frame is extremely limited. Anything outside of that original envelope will result in interference and reduce your print volume. Now this machine has an XY area of 250 by 250 millimeters, which isn't too bad, but every millimeter counts and we don't want to lose any space. Once you have everything successfully positioned, you will need two M3 by 25 millimeter socket head cap screws, and those will pass through the front of the fan shroud, through the extruder fan, through the hot end mounting bracket, and into the original Creality posts that everything slipped over. Once you have the two top screws in place, there is a third one hidden in the bottom, and you can just kind of see it shining through there, and it looks a lot trickier than it actually is. So you can take your hex key and you can pass it through the bottom left hole of the fan shroud, and this is where you would tighten that. But to get that screw in there, you can just simply use some needle nose pliers, put it up into position, and then you can use the hex key to tighten it into place, and that hole will hold your hex key in place while you do this. Like I said, it looks trickier than it actually is. With everything secured and in place, you can rewrap your wiring harness. I would suggest something like a split loom that's much easier to get the wires through. And then you can use your zip ties inside of the strain relief, and you can just push those zip ties in one end and they'll come out the other side because it is a continuous hole. And then you can secure your wire loom in place inside of the strain relief, and that's going to keep any of those wires from being tugged on. The wires for the left-hand side part cooling fan should still be routed through that channel behind the PTFE tube, and that's going to keep those wires from touching anything hot, and it makes the whole assembly look a little bit neater and more organized. Back at the breakout board, we're going to remove two more connectors, and so this one here labeled E is your extruder motor, and we're going to remove that connector. Oftentimes you'll find glue attached to these connectors, so you're going to have to rip that glue off in order to remove the connector. Carefully remove this connector along with the one just in front of it with the black and red wire. That is the connector that powers the fan that constantly blows on the extruder motor on the side of the machine. And so now we can start reconnecting all of the wires from the printhead. So that wire bundle on the right hand side is coming in from the printhead, and those wires have been fished through the black cover that covers all of the belts on the Ender 7. I'm going to start by reconnecting the connector with the two black wires labeled X, and this is the X limit switch, and you can see how it goes right beside the other two limit switches labeled Y and Z. After that, I'm going to reconnect the extruder fan, and so this is the connector with the black and red wire, and you'll see where it gets inserted here. After that, there are the two part cooling fans, and those are the wires that are yellow and blue. Again, there are two of them for the left and right part cooling fans, and those will get inserted up at the top row beside the limit switches. Earlier in the video, I mentioned I'm going to be reusing the original Creality thermistor, and those are the two white wires, so I'll make those connections off camera. The heater cartridge connection is next, and Bondtech offers this product called HeatLink. These are very convenient adapters that will adapt the connectors on the end of the heater cartridge wires to the connectors that come on your machine. So in this case, I got one that converts the heater cartridge connector to a JST XH connector, because on the Creality board, all of these connectors are of the XH series from JST. And as you can see, it now simply just plugs into the Creality board, and I do not need to repin or terminate any of those wires. Last but not least is the extruder motor connector, and this is going to plug into the original receptacle. But before you can do that, you're going to need to reverse the motor direction, and to do that, you can swap two of these pins. So the yellow and blue wires can be swapped, and you can do that using a hobby knife or another sharp tool. There are lots of good videos online on how to repin these connectors, and I had the same problem on the CR10 Smart when I did the LGX Lite install on that in a previous video. But now you can see those two wires are swapped, and you're ready to plug the connector back into the board. And this will now ensure that your extruder runs in the correct direction. Tidy up your wiring and put the original ribbon cable connector back into place at the back of the printer. Secure the belt cover of the machine with the 8 button head cap screws, 4 in the front and 4 in the back. Since we are no longer using the extruder motor on the side of the machine, you can remove that motor, and you can remove the tensioning arm and just use this piece as a filament guide. When remounting the base of the extruder motor mechanism to act as a filament guide, because there is no extruder motor present for the hardware to thread into, you will need to get 3 M3 nylon locking nuts to take the place of the extruder motor. Alternatively, you can leave the extruder motor into place and just remove the tensioning arm such that it does not impede the path of the filament when you're using the extruder mechanism as a filament guide. But I still would recommend trying to remove everything. It's nice just to get all of this clutter out of the way since we're not using it anyways. Plus, if you're anything like me and you have lots of different projects on the go and many different 3D printers, you might find that a spare stepper motor comes in handy in the future. When you're finished reinstalling the base of the original extruder motor assembly, you can now take your original PTFE Bowden tube and insert it back into the fitting at the top of this assembly. The other end of the tube will be inserted into the fitting at the top of the LGX Lite extruder. Before we can start printing, there are a few other considerations, and one of them is the reference voltage on the stepper drivers. The LGX Lite uses a small pancake style stepper motor that is considerably smaller than the very large 60mm stepper motor that comes with the Bowden tube setup on the Ender 7. Therefore, we need to reduce the voltage reference on the stepper driver to reduce the amount of current going to this smaller motor, as we do not want to damage it and burn it out. Looking under the hood of the Creality Ender 7, you'll find the main board and you'll see the stepper drivers with the small heat sinks on top of them. The X and Y are missing as they have their own dedicated drivers external to the main board, and the Z and E are clearly visible here, the lower one being the extruder motor. You'll see me pointing to the trim pot, and this is what we're going to need to adjust in order to reduce the VREF, or what's known as the reference voltage, such that it reduces the current to the stepper driver. A small screwdriver will do the trick, and you're going to want to turn this screw in the counterclockwise direction. You're also going to need a voltmeter to measure the voltage on this trim pot. The negative probe of the voltmeter will go to any ground connection on this board, and the positive probe of your voltmeter will go right in the middle of this trim pot. Based on calculations from a previous installation of a Bondtech LGX Lite on a Creality CR10 Smart, the optimal voltage reference for the drivers that Creality uses on the silent boards is about 0.9 volts. Prior to printing, you will also need to make adjustments to the E-steps. This can be done by connecting your machine to a computer and running a print host, and then using some G-code commands to manually change your E-steps to 562 steps per millimeter. Or you can head down into the video description, click the link to my Printables page for this project, and you can download the G-code file that you can just simply run and hit print, and it will do that and save the E-steps for you. Prior to printing, you should also preheat the hot end and do a final torque on the nozzle tip while hot. And because you have a completely new hot end, I would also highly recommend running a PID auto tune, and there are tons of videos about how to do that online, and on the Ender 7 it is no different than any other Creality machine. Once I was done with all of that, I could prime the nozzle, then let the nozzle cool down. I left the heated bed on, and then I could get into the bed leveling process, because you're going to want to reset your Z offset. In this video, I'm not going to go into depth on the bed leveling process on the Creality Ender 7. I've done that in much greater detail in two previous videos, one of them for the CR Touch installation and another for the triple lead screw bed modification that I've done to this machine. And so if you guys are looking for a good bed leveling process on the Creality Ender 7, go check out my previous videos on this machine. Instead, we're going to get right into printing some more blobs so we can benchmark this new hot end. I started with flow rates from 8 to 22 cubic millimeters per second on this extruder and hot end combination, and it showed absolutely no signs of slowing down. I had a lot more extrusion control this time around because I didn't have a worn out nozzle, but my data still wasn't quite as clean as Stefan's from CNC Kitchen, but that's okay. I still saw no signs of this extruder giving up at 22 cubic millimeters per second, so I decided to keep going. I reran the test from 16 to 30 cubic millimeters per second, and this is where I started to see some drop off. What's strange to me is that the drop off started around the 18 cubic millimeter per second mark, which I didn't see in the previous test because there is some overlap between these two tests. The only variable here that changed was the filament. Now I didn't go to a different brand or a different type. I stuck with the eSun PLA Plus filament, but I only changed the color from orange to gray. Now I'm not a filament expert, so I have no idea if some of the properties within the filaments themselves between different colors would change the flow rate, but I did see a difference here. That being said, the massive under extrusion occurred at the lowest melt temperature of 190 degrees Celsius, which makes a lot of sense because that's very low considering these high flow rates. At 210 degrees Celsius, the drop was about 5% of under extrusion through most of the range of this test, and at 230 degrees Celsius, there was absolutely no drop off at all. On the Slice Engineering website, they claim that the Mosquito Magnum hot end can deliver between 30 and 35 cubic millimeters per second of flow, depending on certain variables like the temperature, filament, etc. Based on the results of my test, I would say that is completely plausible, as I'm seeing easily 30 cubic millimeters per second of flow with a 0.4 millimeter nozzle at 230 degrees Celsius. Now I've yet to push this machine to those limits in practice. I don't feel like I'm going to get great results just yet without more advanced features like linear advance or even input shaping like Klipper has. And that's why I mentioned earlier in this video, that is the next step in this project, and that's to get Klipper up and running on a Creality Ender 7 machine. In the meantime, I've still been printing with PLA at respectable print speeds, and so infill I'm shooting for about 125 millimeters per second, and even my exterior perimeters I'm hitting about 100 millimeters per second. Obviously, hitting those speeds is going to be dependent on the acceleration values that I'm using and the size of the part, such that the print head can actually accelerate to those speeds. In general, I am seeing reduced print times with the Creality Ender 7 over some of my other Creality machines, but I'm not going to sit here and claim that I'm pushing the limits of this hot end just yet. For now, I've been focusing on getting the quality of the parts dialed in, as well as print profiles for more complicated materials such as carbon fiber PETG. With the carbon fiber PETG, I've been having a lot of success with this machine. I switched over to a hardened steel nozzle tip, as well as using the textured side of the double-sided magnetic flex build plate that I have. You guys can find those for sale on my website as well for the Creality Ender 7. And the prints stick extremely well, and they come off very easily on the textured side of the build plate. Every print that has come off this machine has been astoundingly consistent. The PLA prints are extremely nice, and the PETG prints look amazing as well. The only minor issue that I've always had with PETG is the small amount of PETG buildup on the nozzle. Every once in a while, I still get it sticking to the nozzle just a little bit. This usually only occurs on the first few solid infill layers, and if that isn't an issue, then you're pretty much off to the races, and the rest of the print is very clean. In terms of dimensional accuracy, nothing has changed with this printer with the new hot end and extruder combination. I remixed this functional frog box for the purpose of storing the Bondtech CHT nozzle pack. All of the hinges and latches function perfectly, and the box remains fully functional. You can find these files available on my Printables page. And so that's it for this video. I hope you guys are as impressed with this hot end and extruder combination as I am. I think it's really gonna bring this machine to life once we install Klipper. Now, if you guys have an Ender 7 and you're looking to do some more upgrades in the machine, be sure to check out my other videos where I cover things like this triple lead screw upgrade, a CR Touch install on this machine, and in a future video, the Klipper install. Also check out my website, embracemaking.com, where you can find a lot of these upgrades available for purchase in high quality materials like carbon fiber PETG. It's a great way to support my channel and my work if you guys are enjoying this video. Again, a big thank you goes out to Bondtech and Slice Engineering for providing the parts on the hot end and extruder. And another big thank you goes out to Mech Solution for originally providing me with this printer. Also, if you guys are looking to download any of these files for free, check out the video description down below for a link to my Printables page. All I'd ask of you guys in return is to just drop a like on the Printables page. Thanks for watching.